Welcome back. Welcome again, everyone. Okay, so we come to our last presentation of this workshop. Dr. Shirley Dyke, the professor of mechanical engineering and civil engineering at Purdue University, and also the director of the NSF funded multi-hazard engineering collaboratory for hybrid simulation network. Dr. Dyke will be presenting or will be actually discussing with us about the future needs. First, the MEX initiative and the future needs and action plans with respect to hybrid simulation with a focus on like flow structure interaction, hopefully. Okay, Dr. Dyke, it's all yours. Thank you.
Thank you very much. So what I wanted to actually do today was to focus on a discussion to try and engage people in the questions that they have and the things that MEX can do to support the broader real-time hybrid community, the hybrid simulation community, and specifically the fluid structure interaction community. So for those who are not aware, MEX is the Multi-Hazard Engineering Collaboratory and Hybrid Simulation, and we're an NSF virtual community. And what that means is that we have some funds that we can use for supporting the different communities to bring them together, to have meetings, to talk about the scientific needs, the scientific advances, how people could either tackle new problems by networking or having workshops, having webinars and things like that. So what we have as a way to share information, of course, is in DesignSafe is we have a website, and it's actually located on the menu. So if you go to the DesignSafe, you go to the NHERI community menu, you can find MEX, where there's a number of different things here, overview, resources, workshops, and such that are meant to support the community and to give people information if they're trying to get started, or if they want to know about specific topics, or if they want to access publications is more of a more recent thing that we've been focused on. And so the website direct is at the top of this page, but you can get there through this menu from DesignSafe as well. And so let me move this away. So what are the goals of this group of people? It's this research agenda. We've had a number of workshops, which I'll talk about briefly. And the objective of the group is to provide a research agenda, to compile that information into a form that individuals can go and look for research problems they're interested in tackling, and maybe find a group of people who are interested. So we bring people together, peer-to-peer, institute-to-institute partnerships, and we provide training and educational information as well through webinars, through examples, through codes, through links to researchers like the several that have been talking today, and the things that they're doing. We've had two workshops. The first one was in 2017 in San Diego. We had our first workshop, which we called Breaking Barriers and Building Capacity. And we had about 40 or 45 individuals at each of these two workshops. Our second one was held in Zurich in cooperation with ETH Zurich. And that one was called New Frontiers and Innovative Methods. And this was actually the workshop that brought about the subcommittee on fluid structure interaction that is kind of leading this. Professor Alwadi is leading the subcommittee, but that was kind of an idea that was born out of this particular workshop. But each of these workshops has been a really nice opportunity to talk face-to-face about issues. Unfortunately, our third workshop was scheduled last year, March 16th, and we just missed it because of the COVID situation. But the most recent research agenda from the community is posted on the website, and that's kind of broad for all different areas within hybrid simulation. But the subcommittee on fluid structure interaction has just recently put together, and we posted a report on fluid structure interaction. and many, many different applications and success stories and people who've been working, including the speakers who presented in the last few talks. The other thing that I want to mention, though, is that more recently, we've been trying to find ways to remotely support this community. And one of those is the publication library, what we call, and we have about 300 papers that we have linked from this page. You can get there from our main page. And the idea is that you can access papers that are recent, that are in hybrid simulation and real-time hybrid simulation from one central location. And so a number of researchers have sent us papers. We have also dug through the literature and pulled out a number of recent papers. But I would say there's about 300 very high quality recent publications that are located here on all different aspects of hybrid simulation. And if you're interested in adding some, you can email those to us and we will go ahead and add those links. The DOI is the easiest thing to do. We'll go ahead and make those available to each other. So if you're trying to find publications or get started in this area, this is a great place to find some of the papers that could be useful and helpful for you for that. Here's just a few examples. So when you go down, scroll down further on that page, that's what you get. A couple of other things that we've been doing, again, in this kind of remote mode are, one, we had a 3-minute thesis video competition for PhD students, master's students too. And we had about 15 entries, and all of those videos, very short videos, but very well done. We were very impressed with all the students who submitted videos. Are posted in YouTube through our website. You can get to the YouTube channel. But we've also been doing a number of special issues, and I'm hoping that sometime in the next year or two, we can start a special issue in the wind area, or the fluid structure interaction area, with the excellent projects that are taking place, and the one here at FIU and Lehigh working together, and University of Toronto, University of Buffalo in Alabama, and so on. But these are, again, each of these has about 15 different papers. They're all linked from our publication library, but it's really a nice way to give especially young researchers a chance to showcase their work and draw attention to it. So the research agendas for the MEX community, the way that we've kind of organized them is in the following categories. If you look in the document, you can obviously find a lot more information. It's not a long document, it's maybe 8 or 10 pages long, but we really focus on the things that people have been talking about today. The algorithms that are needed, the integration schemes, the control algorithms that are needed in order to really do, especially real-time hybrid simulation, some of those things. The enabling technologies, the actuators, the sensors, the understanding of those, the nonlinearities that we can either impose or that are inherent in our structures. And how does one theoretically, how does one theoretically need to think about these systems in order to configure a test to achieve your goals? And so clearly in the wind area, there are a number of challenges that people have brought up today. Scaling laws being one of them, the need for good control algorithms that can operate very fast to deal with the time lags and such, and also the need for extensive computation with tests like this, because of the complexity of the wind loads and the way that we're trying to capture that within the simulations. A lot of computation is needed, and thus that's a bottleneck in these types of tests. But what I'd like to hear from individuals here, if we have a chance, we have maybe 10 minutes at the end of my talk, is to talk about how we can help with the community building aspect. We've had a few webinars, 1 or 2 linked to wind. We have a couple more planned next summer. But if there's benchmark problems or test beds that we can make people aware of, we can certainly help with different documents like that. One document, of course, is this report. This report that the subcommittee that Professor El-Wadi runs put together, a very nice report with a dozen or 15 different applications from fluid structure interaction and how people are thinking about these problems right now and what problems are being tackled. But I think that there's a huge future in this area. And I really wanted to hear from you guys and talk about how can this community, how can this virtual community support this particular community to help them do their work better, which is really what we're after. So what are the biggest barriers that you guys are seeing? What are the common challenges that people can learn from each other? And what are the opportunities? If you're interested in joining MEX, you can just send an email and say, I want to be added to the list to the mex@purdue.edu to join the announce list. But what I really wanted to talk to you about is to have a discussion about these challenges. And I can, so I'm going to stop there and see if you have some discussion items that you'd like to see.
Thank you, Dr. Dyke. Any questions? I don't see any in the chat, but feel free to say if you have any question. Let me start with two questions that are related, basically related to like expanding the community, bringing other areas of expertise like wind and wave engineering. So I have two questions. So since MEX is funded by NSF, is there any potential like room for MEX to provide like seed funding, for example, for small projects to foster collaboration between different researchers or different institutions?
Yeah, NSF has said that this is not money for research. It's money for workshops. It's money for educational activities, things like that. So we can certainly, and we were going to do this when this was going to be a face-to-face meeting. We talked about actually having a half-day workshop or so with face-to-face discussions, but that kind of changed. But having those sorts of meetings and those discussions, events for students are certainly things that are within our scope. It's just, but NSF has said we can't fund research activities with those things, with those funds.
So. Even for some kind of exploration kind of research topics, like something to try. Like if we want to run like one day of testing at the Wall of Wind, it costs it doesn't cost much, but if we don't have the funding to run the experiment, we cannot do it. So I was talking about these kind of a small kind of experiments.
Right.
But you said no. But you also mentioned that there are some resources for educational activities. So is there plans, or maybe you already have it in the MEX? Because now I'm doing this experiment with Lehigh on real-time hybrid simulation. I feel sometimes we speak different language. Like I have the structural and wind engineering experience, but sometimes I feel, oh, I'm still outsider. I'm not really fully understanding everything. So I was just wondering if there's any courses that different fields can provide in order to bring like a common language between researchers, basically, and doing.
No, that's an interesting point. Let me share, if I can figure out where that was. I had it. The MEX website actually has a lot of information that's like this. So I'm not trying to defer your question. I'm trying to say that there's existing information, right? So one thing that we actually do have is we have a website on learning materials, and there's a link called What Courses Should I Take? So for people who are interested in if people who are interested in learning more about hybrid simulation, real-time hybrid simulation, and the types of things that we talk about in the control world, in the computational mechanics world, these are a set of recommended courses, and we're always happy if you guys have ideas on adding to this. We're always happy to add stuff to this. But if we're talking on the civil engineering side, I think most of the group here is very familiar with that, right? But if we're talking about the control side, digital signal processing, classical control, we have a lot of information about that posted. And so if I go back here, we also have some demo codes and such, and a number of webinars, some given this year, some given last year, in the last 2 years actually, that help us to sort of, I agree with that. There is a vocabulary associated with, am I sharing that screen or did I not share that?
Oh, no, actually, no.
I,
No.
I meant to share it. I thought okay. Okay, you can see this now? Yes?
Now, yeah, I see it now, yeah.
Okay, I'm sorry. I was pointing to the screen. Let me do it again.
That's
So
okay.
really quick. So in the MEX website, if you go to learning resources, we have a number of things here, but if you go to learning materials, there's a list here of what courses should I take. This was something that was an outgrowth of the first workshop that we had, where we talked about it and we had the exact same comment that we don't all use the same vocabulary, and it's a little difficult to draw a dictionary. We do have some documents, which I'll mention in a moment, but to learn different sides of the problem and how to speak those languages and to communicate well, we have a list of some of the courses that are most commonly used in real-time hybrid simulation and hybrid simulation. For instance, these digital signal processing and control theory are some of the major ones. But there's also a lot of other information on here. There's some demo codes that are just MATLAB codes where you can run virtual simulations, educational videos for some of the language and some of the concepts that are used, very short videos, 5 minutes or so. And then we have a number of webinars. Some were from this year and some were from the last couple of years. Again, these are all under learning resources, but we also have benchmark problems, links to data. We have the publication library. We have technical reports. We go back to the 1980s. Some of these reports were originally done a few decades ago in the very early days of hybrid simulation, and they're still very, very helpful to a number of people. So let me mention though the primer is one of the things that is extremely useful. So we developed a primer and dictionary. 2014 is when that was developed. It was before this virtual community was created. And one of the things that, I don't remember exactly where the primer is, but one of the things that we decided was that we were all speaking different languages, and it would be very helpful if we could at least generate some common terminologies and the list of synonyms so that we could have discussions about the types of things that we do in hybrid simulation. And for instance, the discussions about computational delays and time delays today. Does that help?
Yeah, that's very helpful. There is a follow-up question actually related to the same discussion, which I guess kind of specifically asking about online training, like hands-on training for PhD students. I would say also for faculty. Haitham was saying hybrid simulation is almost a black box for students not working in this area. So is there any online training that he can take?
I think that the best thing to do is to look back at these webinars. Some of the early webinars were all about exactly that. Designing a successful real-time hybrid simulation, the anatomy of a hybrid simulation. Those were very fundamental on what you're exactly asking for. So those would be extremely useful for for early training in real-time hybrid simulation?
Uh, Hi, Dr. Dyke. So this is Leon from Lehigh. So one of our collaborative project with FIU, I want to talk about some challenges when we are doing the real-time hybrid simulations under wing. Is definitely what Amal mentioned before is the scale. So for example, when what we are doing, we're doing like 40-story building with a multiple. So first we build a 1/150 scales. So and it's okay when we are doing real-time hybrid simulations. But what happens if we want to do like a full scale or larger scales during the wing? And I think Amal, you can give more. You can jump into this topic too, like how are we going to handling the scale on the wing and also the scales on when we're doing the real-time hallucinations. That's a big challenge for us. So that's what we are working on now too. And we can still foresee there are some difficulties we need to face in the future.
Right. And so this is an ongoing challenge to this community, right? This is a research topic that is of great interest. So if there's a way that we can bring people together to discuss these challenges and overcome them, I think Professor Kwan had a number of suggestions and good examples of what they're doing. And I think we need to learn from each other. Professor Wu also. So we should learn from each other. If there's a way that we can create a workshop and discuss these things, I think that would be fantastic.
Yeah.
I know this is a workshop to do that, but I also know that this is the facility workshop. So we could have a separate workshop at another time to discuss this because it does really require interdisciplinary individuals, right? We need to understand the wind side. So we need to include Professor Alwadi and such. We need to include the structural side. We need to include the control and the simulation side, right? So there's a lot of different players that have to address these questions, which is actually one of the reasons. So I don't know if you're aware, but there's this building capacity mode that universities, that NHERI facilities, I should say, are able to explore. And I think that is one of the ways in which you guys started exploring this topic together. So that is certainly a possibility for NHERI facilities, right? The building capacity option. So how do we do that, Liang? How do we bring the group of people together? Do we have a workshop at some point in a couple of months? We have a half-day discussion about these topics?
Yeah, definitely. I would like to, if we can have a like workshop together. Like for example, when we are doing real-time simulations, we have a limited knowledge on the wing, especially when we are bringing the aerodynamics. So we talk with the FIU, we ask FIU's help. So yeah, if possible, we definitely can have a workshop together to discuss all the challenges and introduce our solutions too. If anyone can help.
No, I think that that's a great idea. I mean, we've had these discussions, but the last one really was about a year ago, right? We had two conversations, one in San Diego, actually 2 years ago, one in San Diego, one in Zurich. And it's been 2 years since that conversation. I know that a lot of progress has been made. It would be nice, and also the report that you guys have documents a number of things people are thinking about. I think that is the starting point for such a workshop, is for anyone participating to go through that document and learn as much as they can, first of all. I think that's critical. And then to still try and say, what are the challenges that we need to address? Because there's a lot of them. I mean, in terms of wind, I think it has to be real-time hybrid simulation. The opportunities for pseudodynamic or regular hybrid simulation, depending on what you want to call it, are very limited if they exist. So real-time hybrid simulation is where you have to do that type of testing, which means accelerated testing, lots of computation, and very short period of time. So.
Yeah, hi Shirley, this is Jim. It was very, very interesting presentation. I just had a comment, and it kind of comes back, there's a chat, and I think this is a good opportunity to raise this, where Hakeem has indicated he's a PhD student and indicates that hybrid simulation appears to be a black box for students not working in the area. And I think what you point out was very important, where you listed some curriculum that there, and I think that's kind of key, really trying to understand a little bit of the background. Now, maybe for those that are graduated, there's still topical areas that they need to pursue. And my own personal experience, I found it very important to try to, you're not going to be knowledgeable in all the areas, but you do have to have some fundamental understanding in certain parts that you want to contribute to. So I think it's very important to take advantage of the, let's say the sound solid papers or references have been written that one can, like it's documented here, that can get that knowledge. One thing I would suggest, surely, to add to this list that I found was beneficial to me, and I think others, is numerical methods. It sort of is ingrained, if you wish, in all these topics, but understanding numerical methods, about stability and eigenvalues and matrices, and as you know, with parallel processing that you've done, you had to separate out computational calculations. I think that would be also beneficial to add as possibly another entity into this. And it's really ties between civil and non-civil.
That's a good point, Jim. Adding numerical methods to this would be a very good idea. We usually learn it sort of through finite elements, but it would be always better if it's in a separate class. But on the right-hand side, you're right. Digital signal processing and control theory. A typical first year graduate course in control theory, those are the two keys to really being able to understand these methods, in my experience.
And coming from a civil engineering background, I found when I started to look at controls and other things and other aspects, it really helped, because it sometimes actually would be able to explain things in a much more organized, robust manner than if you took the traditional civil engineering approach and used something different. So I think this multidisciplinary part's important. One other area too, a little bit, is on the servo control, surely, is the servo hydraulics, servo valve dynamics and other things, which I don't know where that would fall. What do we call that? Servo? It's really like hydraulic fluid. It's not strictly fluid mechanics, but yes, it's the actuators and the nonlinearities that modeling of the hydraulic system and those things. Now maybe that's under their control, but I found that somewhat useful as well, at least to understanding it, maybe not dealing with it directly, but understanding some of the phenomena that affect the outcomes of hybrid simulations.
Right. Usually that would be in a course either dedicated to hydraulics, or it would be in a first semester controls course from a very basic level. So you would talk about the linear dynamics of hydraulic actuators, but you wouldn't separate them very much from DC motors or anything like that. So these two videos that I'm showing, even though they're short, they give an introduction to some of what we're talking about. So there's one on PID control, that's the second one. And the first one is just on hydraulic actuators. One of my students made these last summer for exactly this purpose, for people to kind of get a little bit of a feel for some of the language that is used in those fields, and an intro to what they might learn in a course. In my mind, my PhD was in structural control, so I took a controls class and a digital signal processing class while I was in graduate school. And it's sometimes I forget that not everyone does.
No, surely I find it interesting though, because I think you and I come from different angles or backgrounds, yet we're converging towards a common aspect, right? Because hybrid simulation is very multidisciplinary, I find. So the more interactions you have with others that come from different backgrounds, I think that's how also you learn. You may not realize something or where the, you know, the milestone papers are, that if one were to be like you pointed out here, I think that really helps to interact with people that are from different backgrounds, because I feel it's a very multidisciplinary discipline, you know, hybrid simulation.
And it's not magic, it requires hard work. Just like any course, just like finite elements, it requires you to dig into the math and figure out what you're learning about and do well on your tests. So
Shirley, one last thing is, I'm wondering, is any people in the faculty in the academia there that teach experimental methods? You know, there's some disciplines have experimental methods in the civil side, as well as the, I'm sure on the mechanical side, that incorporate hybrid simulation into some of the experimental methods. I know I've been pushing for it at Lehigh to try to, you know, go to a new level there, but I'm curious, but if anyone else has thought about that or has implemented that.
Yeah, I've taught an experimental methods class every 2 or 3 years, and it varies a little bit. So I taught it in 2015. I called it structural control. I'm teaching a course now, and I'm calling it experimental testing, or something like experimental structural testing. And it changes every time based on the students that are in it. So we do it, but it's more periodic. When I was in my previous university, I taught it every 2 years. And now I don't anymore.
Yeah, I mean, the reason I mention that, because I find like Amal is looking for new knowledge, and you know, we learn different ways, you know, reading, seeing, hands-on, and I think what's important is to have hands-on experience where you learn something bit by bit, and then you try it with hands-on, and then you can think of it in your own way and understand it. And so that's why I'd ask about something of a, if anyone's teaching courses, that it presents the opportunity to get more hands-on experience for people that want to learn. And I think that's really an important aspect.
If I can add to that, or if MEX can provide like access to students or faculty who would like to attend one of these courses, because sometimes it's difficult to locate like where is the course is being taught and how we get access to it. That's one of the challenges.
Okay. Let me think about that.
This is from Buffalo. We are here, Buffalo. Dr. Silva actually also have been teaching the experimental method each 2 years, if I remember correctly. Just for this information.
I don't know if it was clear, but Teng, I didn't hear you well. I'm not sure if the problem from my end.
Oh, just just trying to respond.
Yeah, now it's better. I hear you better.
Just trying to. Can you hear me clearly?
Yes.
Yeah.
Oh, okay. So I just want to try to respond to Dr. Likra's question. At Buffalo, and my colleague, Dr. Silva, also have been teaching the experimental method each 2 years. Depends on the students, and sometimes each 1 year.
Yep.
Well, maybe I'll reach out to you, Tang, and we can talk a little bit about that and try to, I don't know, let me think about that. I mean, we kind of hope that some of the webinars, the hybrid simulation 101s would have that. In fact, the document I'm showing here is the primer. It's on this was developed in 2014, but it's still quite true today. Everything in it, nothing's outdated in this document. It's a primer for students, for people who are interested in just starting hybrid simulation. It has a very nice overview that is not really domain specific and not method specific, but it's meant to be a nice summary of different components, what we call them, what their role is, how do you do this. I remember when I was starting to build a laboratory for real-time hybrid simulation, and I remember thinking, how do I know that I buy the right stuff, that it all fits together? That was the thing that I was the most nervous about. because and then I discovered some of the tools that like MATLAB offers, and even though I knew how to use hydraulic actuators and I knew how to use controllers, using them together, I was afraid to buy some of that equipment, right? And so this tells us what are the different components and what is their role and what can you do? And this document is very helpful for that reason. And then there's also this terminology, which I admit was Naru Nakata, who used to be in the US, but now he's in Japan, was the one who put together most of that terminology. And it's really helpful because it has synonyms and antonyms for the different, I'm scrolling really fast, I realize. But it has, for instance, actuator, controller, actuator dynamics. It has definitions for these, and then it has a list of synonyms, right? And the synonyms are really helpful for people trying to read papers from different sources, and people use different terminology, and it's really the same thing. So people starting off, this is a great document. I still think, even though it was 2014, I still think it's a very useful document.
I agree with Charlie's comment. I think first thing for a new beginner in hybrid simulation should be familiar with this primer. But at the same time, different groups run hybrid simulations in a very different way with different hardware as well. Some groups use analog I/O for communication with the controller. Some groups develop their own hydraulic control as well, while some other groups use D-space card or scramnet card, something like that. So learning these basics is one thing, but when unless someone really put their hands on and trying to do something, it's really hard to assimilate the topic. So I think it'll be also a good idea to have even if it's not a real hydraulic system, having a small scale system that new beginners can put their hands on and try to develop their own numerical model, even if it's just a matrix form, and connect it to the device. In a sense, in a similar way that educational shaking table has been very popular about in 2000s.
Right. And I believe we have some links because Professor Kwan actually created such a small experiment a year or two ago. And I think we actually have a link to your website from MEX that provides people, if they want to build that, they provide a link to your documents, if I remember correctly.
I need to take a look whether my website is still
okay. That's always the problem with websites, right?
Yeah.
But yeah, we're trying to just, provide as much useful information. And by the way, if you go to resource quick links, background documents, that's where the primer is. There's so much information in this website, it's hard to keep it all completely organized. But this primer is really an important document, and the publication library, all the special issues are linked from the right-hand side here. Publication library, you can just click on this and it'll take you right there, okay? So this is really helpful. I'm gonna repeat that the primer is also the subject of the webinar called Anatomy of a Real-Time Hybrid Simulation, or Anatomy of a Hybrid Simulation. It's someone, Gabby O, presenting the primer. She helped to generate the document when she was a PhD student. And when she started as a faculty member, she did a webinar on that document, the primer. So watching that is really one of the key things I would do to start off with.
We have additional questions in the chat. So Dr. Ashrafi is asking, how can we participate in subcommittees out of the United States? And can we share our field and experimental research as well as webinars and workshops too, like I guess VMX?
Yeah, absolutely. I mean, everybody is welcome to join MEX. We are announcing the information. You can go to the website, you can join the workshops. Everybody is welcome to do this. You can send us your publication links and we'll go ahead and add them to the library. We want it to be useful for everyone, and we want people to build those partnerships. So the more the merrier. We're trying to help everyone. I can't fund people outside of the US to go to the workshops, but if we have a workshop out of the US, when the time comes and we're able to do that again, then we can come to them, right? That is an opportunity.
That's great. Another question from Xiaoji Wu. Forgive me for the bad pronunciation. Has the airplane industry done similar real-time hybrid simulation tests that we can learn, or maybe we are using some of what they have used or learned?
That's a good question. It's an argument that I've had with many people. So I don't think that the aerospace industry is really doing real-time hybrid simulation. They do other things that are similar but not the same. There is hardware in the loop, which is used quite extensively in electrical and computer engineering, or mechanical engineering. Sorry. I view that as being different. It's hard to really distinguish what's different, but that's my opinion. Other people may disagree with that. In aerospace engineering, they've historically used something called component node synthesis, or they've done tests where they generate the time history, the input motion offline, and then they put it into the test specimen, and they try to ensure that the boundary conditions are met. So all of these have their own purposes. None of them is better, but I think the challenges in civil engineering are that these structures are so big that we need to find a way to test them inexpensively. We don't have the same resources that they have in the aerospace industry. But we do have serious concerns that have to be addressed. And this is the way that we've tackled it. I think it's unique. I don't think that it's being used extensively in other fields. I'll mention that I have a NASA project right now, and we're trying to explore how to do this for space structures. But it's a multi-physics version of hybrid simulation. So it's very young at this point. So we haven't done much. So it's a good concept, but we haven't gotten very far yet. So.
Yep. There's a popular demand about, like, can MEX fund one of this experimental course and give free online access for the community? I think there is like multiple requests about that now.
Let me try to explore that. Let me try to figure out how to do that. And what, I'd really like to hear from people what would be the content of that course if we were to do it. So, I mean, we've been putting together, obviously it needs digital signal processing, it needs data acquisition, it needs all of those skills. But then it also needs the community, individuals with the expertise in, say, wind and fluid engineering, right? It needs those different folks. And that's kind of what we've been doing with the webinars, but let's try to figure that out. Yeah, I would love to explore that. So.
Sounds great. So there are multiple questions from Ryan. Ryan, if you please can maybe summarize your questions, because I see like long discussion here in the chat. I think it would be more effective if you can just discuss it quickly with Dr. Dyke. If your mic is on. So the two questions, I'm not sure if Ryan is still here. Will a proper hard real-time operating system help researchers to improve the performance of current real-time hybrid simulation algorithms and obtain more realistic measurements on the time delay? That's a technical question.
So most of us are using a real-time operating system. Most of us are using DSpace, SpeedGoat, those types of systems, XPC. So we are already doing that. When we talk about the time delay, I don't know if you're talking about the time lag or the computational time delay in that question. But it's not a matter of measuring it, it's a matter of controlling for it. And so I would love to have Ryan send me an email and talk to him about this a little bit. But most of us are already using real-time operating systems, and it becomes an issue when the computation gets big. We either miss the timing or we actually overshoot. We use too much time to do the calculation if we're not using a real-time operating system. Again, in my opinion, these are all my opinions. Have you ever compared
I think,
performance?
yeah, okay.
No, to my knowledge, we haven't directly, I'm addressing number 2. We haven't directly compared them. I've had some issues with LabVIEW myself with their controllers in the early days, like 2000 or so. So I don't usually use LabVIEW, but I know that the newer systems from LabVIEW are much better than the previous systems. So there's not been a direct comparison of hardware to my knowledge. Jim, do you know of any?
I'm sorry, Shirley, what was the question again?
Do you know of any direct comparisons of different types of hardware for real-time operating systems?
Hey, Jim, this is Tommy. I'll jump in on that. Yeah, there really hasn't been. I mean, I know some sites use LabVIEW real-time. I don't use it at all for any of the stuff. I've contacted both DSpace. I've contacted Concurrent RT. I know they're another company. They have like this thing called like a Linux Fire. I forget what it's called. They're all kind of the same. You know, you're always going to be limited to the CPU technology and how well you partition things across multiple CPUs if you're able to parallelize things. Again, CPU is going to be the same no matter really what interface you're using when it comes down to like the raw arithmetics of, you know, of the logic cells. So I would recommend if you're going to want to look for more performance, FPGA technology is probably the next step into looking at, you know, increasing performance with that. So there's always going to be there is going to be some advantages on FPGA technology, but you know, if you're looking for just like raw power, CPUs are always going to be the best, but it's always going to be up to your platform of choice.
Right, and some of the LabVIEW systems use FPGA, just to answer that question.
Correct, yeah, most LabVIEW implementations leverage FPGA, correct.
Great, is there any additional question for Dr. Dyke?
No, I was just gonna say maybe some sort of primer document that relates to these questions would be helpful in the future. Like especially things like hardware, things like algorithms, maybe we want to have some sort of summaries associated with that. Anyway, I'll think about that. And I'm happy to get emails from anyone either through the MEX list where my students will forward this to me or directly to myself.
So do you think like a revised version of primer, including flow destruction interaction terms, would be needed, or it's already there, like the terms are there? I mean, the flow destruction interaction subcommittee can work on that if you think like some missing areas are there.
Well, there probably is a little bit of missing stuff, but it's probably just in the partitioning. So it's worth looking at. So let's take a look at that offline and see if there's a way to generate that. That'd be great.
Yep. Yeah, sounds great. So if no further question, thank you very much for your time, Dr. Dyke.